A piece of depth detective work emerged on Wednesday from Boulder, Colorado, where atmospheric scientists announced that recovery of the Earth's radiation-shielding ozone layer by mid-century faces a new threat: fresh emissions, probably from Eastern Asia, of an ozone-eating chemical whose production was banned by international treaty 3 decades ago. The chemical is known as CFC-11, which is less of a mouthful for non-chemists than trichlorofluoromethane. It was used as a refrigerant, a solvent, a blowing agent, for polyurethane insulating foam and packing material, and as the expanding, contracting fluid in those little drinking bird toys. Like other chlorofluorocarbons, CFC-11's breakdown products in the atmosphere include chlorine, which severs the bonds that hold trios of oxygen atoms together as ozone. Under the Montreal Protocol of 1987, production of CFCs and other ozone-depleting chemicals were phased out. Production of CFC-11 was supposed to stop in 2010, but official reports to the United Nations show it had fallen nearly to zero by 2006. This doesn't mean emissions of the chemicals themselves fell to zero. In fact, CFC-11 continues to contribute about 1/4 of all the chlorine reaching the ozone layer, as it leaks from old refrigeration equipment and insulation exposed when buildings are demolished. Still, atmospheric levels should be falling steadily. And they aren't. Based on data collected since 2002 from air sampling instruments around the world, researchers led by Stephen A. Monska of the National Oceanic and Atmospheric Administration's lab in Boulder found that CFC-11 concentrations had declined at a steady rate for 10 years. But something changed in 2012, a 50% change from that year onward. The decline slowed to half its former rate. No such slowdown was observed with other long-lived gases, so the change with CFC-11 didn't seem to be driven by some kind of general shift in stratospheric conditions. It was happening more in the northern hemisphere than the southern. This was significant because the chemical was manufactured almost entirely in the industrial north, while finished products containing it were distributed more evenly around the world. And there didn't seem to have been any major surge in teardown of buildings where the chemical was banked. An excerpt, lightly compressed, from Monska's paper published Wednesday in the journal Nature. It seems unlikely that the increased CFC-11 emissions are related to faster releases from banks or from inadvertent production. Increases in bank-related emissions are thought possible from the demolition of buildings that contain CFC products, although these emissions are expected to be small and only slowly increase over time. Furthermore, an increase in CFC emissions resulting from the decommissioning of buildings is anticipated to occur initially in developed countries in which most CFC-11 was used in the 1970s. Atmospheric measurements suggest a decline in U.S. emissions from 2008 to 2014, which is consistent with inventories. If reported production values are accurate, our results would require a doubling in the fractional release rate from CFC banks over the past 15 years and a substantial increase in emissions from banks since 2012, both of which seem improbable. Having eliminated those explanations, he writes, the data suggest that the increased CFC-11 emissions arise from new production not reported to the United Nations Environment Programme Ozone Secretariat, which is inconsistent with the agreed phase-out of CFC production in the Montreal Protocol by 2010. Pinpointing where that unreported, treaty-violating production might be occurring is obviously difficult from the limited array of sensing equipment devoted to this research, a dozen stations scattered from the South Pole to Greenland. But there are clues nonetheless in fluctuations of CFC-11 and other gases detected in the monitors, especially the equipment at Mauna Loa, in Hawaii, and also in the times of year when they occur. All in all, Monska writes, this evidence strongly suggests increased CFC-11 emissions from Eastern Asia after 2012. There are other threats to the ozone layer, he says, but their destructive potential is smaller than the new and unmonitored CFC-11 production that seems to be driving his data, and threatens to push back the ozone layer's recovery to the healthy levels of the early 1980s, a goal currently projected to be achieved sometime around 2050. Progress toward it has been steady since the protocol took effect, at least until now. This is the first time that emissions of one of the three most abundant, long-lived CFCs have increased for a sustained period since production controls took effect in the late 1980s. A delay in ozone recovery and enhanced climate forcing is anticipated, with an overall importance depending on the trajectory of CFC-11 emissions and concentrations in the future. The Meaning of Montreal. In a commentary on Monska's paper, in the same issue of Nature, British meteorologist Michaela Hagelin assesses the work as rigorous in its deductive approach and elimination of natural variables, along with its close analysis of telltale distribution patterns for CFC-11 in the two hemispheres. She also reminds us that the Montreal Protocol has been hailed as the most successful international treaty so far that deals with a global environmental issue, and concludes, Monska and colleagues' study highlights once more that environmental regulations cannot be taken for granted and must be safeguarded, and that monitoring is required to ensure compliance. Continuous observations of the environment are crucial. ******* The Monska paper, an unexpected and persistent increase in global emissions of ozone-depleting CFC-11, can be found here but access is not free. The Hagelin commentary can be read here without charge.